All right. So before we look at all build any sophisticated models here, and usually it's very very useful look at some of the basic statistics of those features here. For instance, we might want to know what are the average values of each individual features. And average means that they are average across different samples. For instance, we might want to know what's the mean, what's the medians, and I want to know what's the spread of the data sets here. For instance, it might be good to know what are the standard deviations of each individual feature across different samples, and what are the max and minimum values of that. You can all generate those values, create those values in Python through a very simple script, and I encourage you to take a look at those, run those scripts in the Python, get those values, take a look at it yourself, right? And another very useful tool is to kind of generate something called histograms of each individual features here. So histogram means this. So essentially, we're going to count the data following each individual pre-specified number of bins, right? So for instance, this, let's say this, we want to look at the distribution of one particular feature. Suppose, let's say, we want to look at the sepal length. So sepal length here, and so look at, so we can look at the sepal length here. So these are, we say the values range from 4 to 8 here, and then I'm going to generate a few bins within. So now we have probably 20 bins here, 10 or 20, 15 bins here, and then we're going to count how many samples are located within each individual bins here. And then we count them, and then we plot the number of samples within each bin as the functions of the center of the bin. And then by doing that, we get a kind of graph look like this, and then we call it histograms. So histograms, it roughly tells you the distributions of the features across different samples. And those histograms are very useful, very informative. So for instance, I look at it here, I have an idea, say, well, this data set here seems like a range from 4 to 8 here, and with means roughly around this 6 here, and with spread goes from 5 to 7 here. Majority of them are located within this range of them. So that's very helpful, give you a rough sense what the data look like here. And then in the Python, you can plot these histograms using a very simple program called HIST, H-I-S-T. And with your data sets here, you specify the number of bins and you'll be able to show the plot right away. So that's always a very useful tool to use, and you can see results of that. This is called a histogram, very helpful. So the second kind of a very simple data exploration techniques is do a scatter plot. So scatter plot is that, so the histogram, we try to generate distribution of one particular feature, right? The scatter plot, we actually plot data in a two-dimensional space and plot the relationship between two features. For instance, in this case here, I try to plot the feature x1 versus feature x2 here. So in this case here, one dot here represents one sample. So because that sample, I know what is the, suppose the sepal length, I plot the sepal length along the x-axis and I plot the sepal width along the y-axis. And then I can pinpoint the locations of these samples here. And then I plot all the samples here, and you get a sense of what this, for the entire collection of samples here, what is the first two features will look like here. And that's something called a scatter plot. Of course, you can do a scatter plot for any pairs of features. So right now you do x1, x2, but you can do between x1, x3, or x3 and x4 doing that. So that will be a very useful tool to do as well. So by look at the scatter plot here, you can see how the data what the data distribution will look like here. And if you look at it here, you can see, well, you can look at here, there's roughly there are two groups emerging from the scatter plot here. You can see there's one group here, there's another group here. And then naturally you will ask you here, are those groups here associated with different classes of these flowers? And the answer, it turns out to be yes. Yeah. So you can also put all the things together here, plot, you can all pairwise scattering plot, and then you can also plot all histograms of each individual features here. So that will be histogram of the first feature, histogram of second feature, third, and so on, the fourth features then. And this will be the scatter plot of x1 versus x2, this is x1 versus x4, and you get all this kind of distribution look like. So this for this kind of small data set, that will present you the very clear picture of the entire collection data sets will look like. And without applying any sophisticated machine learning algorithm, you already see interesting patterns emerge from this kind of data representations here. For instance, you can see clear separation of the groups from here, 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 and here as well. And as you can see clearly, if you want to make a prediction or data exploration or discovering patterns, it's very easy for you to look into each individual components of that and to see if it makes sense to separate data into two groups, two different clusters of that. So it's always useful to use this type of scatter plots. All right, so let me see, I kind of, let me actually pause here. I don't want to overwhelm you with too much information here. So my goal of this kind of today's class is not very ambitious. I'm trying to kind of give you a rough idea and what this class we're going to talk about here, and then kind of go over some of the logistics of this class here. We're going to complete the remaining kind of part on Wednesday's lectures here. So before I actually end today's sessions here, let me actually pause